Hello and Assalamualaikum everyone. My name is Nik Muhammad Nakif bin Nik Kamaruzaman. My metric number AP19285. Today I am going to share with you about flow in pipeline, which is laminar and turbulent flow. So, in this chapter, you begin to develop your skill in analyzing the energy losses that occur as fluids flow in real pipeline system. The only type of energy loss considered here is energy loss due to friction in straight circular pipe or tube. Characterizing the flow as laminar or turbulent is the first step in calculating friction losses. You must be able to determine the Reynolds number that is depend on the velocity of flow, the size of the pipe, and viscosity of the fluids. So, I am going to share what is laminar and turbulent flow. So, laminar is happen when it's occur when fluids flow in parallel layer with no disruption between the layer. At low velocity, the fluid tends to flow without lateral mixing and adjacent layers slide past one another like playing cards. There are no cross current perpendicular to the direction of flow or eddies or swirl of fluids. In laminar flow, the motion of the particles of the fluids is very orderly with all particles moving in straight line parallel to the pipe walls. Any lateral missing means that missing at right angle to the flow direction occurs by the action of diffusions between layers of the liquid. Diffusion missing can be slow, however, if the diameter of the pipe of tube is small, then this diffusive missing can be very significant. So let's see what is turbulent flow. The turbulent flow is a flow regime characterized by chaotic property changes. These include rapid variation of flow of pressure and flow velocity in space and time. In contrast to laminar flow, the fluids no longer travels in layer and mixing across the tube is highly efficient. Flows at Reynolds number larger than 4,000 are typically, but not necessarily, turbulent, while those at low Reynolds numbers below 2,300 easily remain laminar. Flow in the range of Reynolds numbers between 2,300 to 4,000 and known as a transition. So meaning that we can conclude that laminar have a low velocity. Meanwhile, turbulent flow has a highest velocity. As you can see in this picture, here the application of flow of laminar and turbulent flow, which is in the pipe line system. Is pipe. So from the pipe, laminar have low velocity means hence turbulent flow has a highest velocity. And you need to know that laminar must be less, the Reynolds number must be less than 2000, and turbulent flow must be higher or more than 4000. So my question about laminar and turbulent flow is, what are the major difference between laminar versus turbulent flow? As you can see in this picture, uh, this is a transition picture, transition laminar and turbulent flow. So first you need to know how to calculate the Reynolds number, and when you get the answer, you can determine uh, the which flow. If the flow if the Reynolds number is less than 2000, means it's laminar flow, and if the Reynolds number is more than 4000, it's turbulent flow. That's all from me. Thank you.
Hi, my name is Muhammad Ahmad Korin. My metric num ID is AB19167. Is your second presenter. I will tell you the difference between laminar and turbulent flow. For laminar flow, the Reynolds number usually is below 2000, and for turbulent flow, it is more than 4000. For laminar flow, it has low velocity, but for turbulent flow, it has high velocity. As you can see from the first presenter describes, also have the picture of the flow, you would see that the difference of the velocity. Also, in laminar flow, the dye does not mix with water, but in turbulent flow, the dye mixes rapidly and completely. For laminar flow, it is a simple flow which the fluid particles move in straight lines. But in turbulent flow, the particle path is completely irregular. As you can see from my second slide, which is the laminar and turbulent diagram, you can see that the flow is very irregular, which is like that. You know what I mean? Yeah. And then also laminar is a simple mathematical analysis, which is it is possible to analyze the flow. But as for turbulent flow, the mathematical analysis is very difficult, so experimental measures are used. Laminar flow is very rare in water systems because it is too simple, I guess. Also, the turbulent flow cannot be seen by the naked eye. It changes or fluctuations are very difficult to detect. We must use laser to identify it, to detect it. But the turbulent flow also is the most common type of flow. As you can see in my second slide, you will see that the laminar and turbulent flow path suits the difference that I have mentioned earlier, which is, as you can see here, the laminar flow, the fluid particle moves in straight lines, but the turbulent flow moves irregularly. Also, as you can see, the velocity when it is a straight line is low, and when it is when the path or the movement is irregular, it is high. The velocity will be high. So what I'm trying to say here, the diagram here, the laminar and turbulent diagram here, suits the criteria in the difference I've mentioned earlier. That's all from me, your second presenter. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Arifan bin Ali Zaini and my matric number is AB19105 and I am the third presenter of my team. Okay, I will proceed our presentation by the topics Reynolds number. Osborne Reynolds is the man who popularized the concept. There is the picture of Osborne Reynolds on the right of the slide. Why is so important to study Reynolds number? Reynolds number help us to predict the pattern of the flow in pipelines. By Alma says in earlier, low Reynolds number are tend to be laminar and high Reynolds number are tend to be turbulent. The formula of Reynolds number are density of the fluids multiplied by velocity of the fluids multiplied by characteristic length over dynamic viscosity and can be simplified as velocity of the fluids multiplied by characteristic length over kinematic viscosity. If Reynolds number are below 2000, the flow is laminar, and if the Reynolds number are above 4000, the flow is turbulent. If Reynolds number are between 2000 and 4000, it is called critical region because it's difficult to predict either the flow is turbulent or laminar. Okay, let us take a look at this example. By this question, we know that the density is 910 kilogram over meter cube and the velocity is 2.6 meters over second and the characteristic length is 25 millimeter. It is equal to 0.025 meter. And lastly, the viscosity is 0.38 Newton second over meter square. Now, we have to put this information into the Reynolds number formula. Re equal to 910 multiplied by 2.6 multiplied by 0.025 over 0.38. And the answer will be 156. So we can conclude that the flow is laminar because the Reynolds number is below 2000. Okay, that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. I am presenter number 4, Lutf Munir bin Mustafa, with a matrix ID of AB19174. So, I will be continuing this presentation with Darcy's equation. Darcy's equation, the general energy equation, is what is stated in the slide right now. The HL is defined as energy loss in the system. Darcy's equation, HL equals to F times L over D times V squared over 2G, where HL is the energy loss due to friction, L is the length of flow of stream, D is the pipe diameter, V is average velocity of flow. And finally, F is a friction factor. Next, friction loss in laminar flow. We can use two calculations for this. Energy loss due to friction can be calculated by using these two calculations, which is using the Hagen-Huisel equation and Darcy's equation. So we will look at the example 2, which is, it states here that determine the energy loss if glycerin at 25 degrees Celsius flows 30 meters through a 150 millimeter diameter pipe with an average velocity of 4 meters per second. First, we have to analyze all the important keys. Firstly, it is, what does this question want? This question wants the energy loss. So what is the object used? It is glycerin. The temperature, it is 25 degrees Celsius. The length of it is 30 meters. The diameter is 150 millimeters. And it has a velocity of 4 meters per second. So according to Darcy's equation, we can find the energy loss very easily. So I hope that you can try this yourselves and continue learning fluid mechanics. That's all from me. Thank you.
Hi and Assalamualaikum. I am presenter number 5. My name is Andi Khairul Hakim bin Ahmad. Number ID AB19256. Okay. Today I will continue the presentation and tell about friction loss in turbulent flow. Okay. For turbulent flow of fluid in circular pipe, it is most convenient to use Darcy equation to calculate the energy loss due to friction. Okay. Turbulent flow is rather chaotic and is constantly varying. For this reason, we must rely on experimental data to determine the value of F. For the model diagram is used to help determine the value of the friction factor F for turbulent flow. Okay, the value of the Reynolds number and the relative hardness must be known because you need to use the value in the model diagram to find answer for friction factor. Okay, therefore the basic data required are the pipe inside diameter, the pipe material, the flow velocity, and the kind of fluid and its temperature from which the viscosity can be found. Okay. Next, this is a model diagram, and you need to use this model diagram to calculate friction loss.
Okay, next example 3. The question, determine the friction factor F if a liquid is flowing at 5 meter per second in a pipe having an inside diameter of 122.3 millimeter with length 100 meter. Given HL 18.8. Okay. First, you need to use this equation. HL equal F times L over D times V2 over 2G. Okay. Okay, you must make the discussion to this. F equal HL divided by L over D divided by V2 over 2G. Okay. Put the value. F equal 18.8 divided by length 100 over diameter, and you need to convert millimeter to meter. Okay, 0.1223 also divided by 5 square over 2 times 9.8. Okay, let's calculate this value, and you got F equal to 0.018. Okay. This is the equation, the answer.